right, we're recording now. And here we are starting chapter 6, where we will go into a fair amount of depth into the parallels and the relationship between algebra and geometry. By the time you're done high school math, if you stay in the pre-cal program, you won't even think of coordinate geometry and algebra like they're different things. They're basically just two different expressions of the same ideas. So this shouldn't be a new concept to you, although the grade 9 curriculum actually does. The textbooks that we use in grade 9, they tend to avoid this word. I'm sure your teacher used it all the time because it's almost hard to avoid this word once you get used to thinking of it. But the word slope is the rate of change of a line. Oops, that's an E. The rate of change of a line. So we like to symbolically represent this as delta y, where delta means it's a Greek letter that usually we associate with change. So it's the change in y divided by the change in x. We also symbolize it with a lowercase letter m, and sometimes we refer to it, and this is the way your grade 9 teacher would have mentioned it, as the rise divided by the run of a line. Remember that we always think of this coordinate plane as just two-dimensional. It's two directions, right? You can go back and forth, which is the x direction. You can go up and down, which is the y direction. So the change in the x direction, which is, I don't know how well this copied, but this line that I'm highlighting in red here, that's what we call the run. And the change in the vertical direction, which I'll use the blue on here, that's the rise. So rise divided by run is what we call the slope. It's a ratio, and it's always for a straight line the same number, anywhere you pick on it. Okay, so there's the formula for it. Change independent variable over change in independent variable, which we might want to think of as, again, change in y divided by change in x. Those are supposed to be Greek letter deltas. And let's take a look at, first of all, this is what yours has as the next thing. What does it mean to have a positive slope? So on your page, you're looking at the positive slope. Don't worry, I'll come back to those examples. It's just in a different order on your page. Positive slope means that the run is positive. So that's a positive denominator. And rise is positive, which is a positive numerator. So rise over run, maybe I should put that down here again. Rise over run is positive divided by a positive. And think back to your integer knowledge. What happens when you divide two positives? You get a positive number. So you can write this down, and I know you have less space to write than me, so you might want to write small. You can think of this as, on a graph, a positive slope increases in y from left to right. So as I look on this page from the left to the right, that way, the line's going up. That's why it has a positive slope. Okay. For a negative slope, and again, yours is just to the right on your page. For a negative slope, rise divided by run, well, as you can see, to go from left to right, I have to go down, and down is the negative direction on a grid. Run is still going from the left to the right, so that's still a positive direction. And a negative divided by a positive is a negative. So I'll fill that in with on a graph, negative slope decreases in y values from left to right. So again, hopefully you can write small enough to fit those on your page. What if you have just a horizontal straight line? Horizontal straight lines have what we call 0 for a slope. Because the rise divided by the run, well, let's see, how much from this point to this point? So this is my line here. How much does it go up between this point and this point? And the answer is, well, it doesn't go up at all. So the top of this fraction is 0. Now the bottom of this fraction, let's count it. 1, 2, 3, 4, 5, 6. But really, does it matter how far it is? What's 0 divided by any number, whether it's 6 or a billion? Yeah, 0 divided by anything is, of course, 0. So the slope of a horizontal line is 0. Okay, and lastly, an undefined slope. So an undefined slope has a rise divided by a run. Well, let's see. Between these 2 points, we rise. Now, it's kind of hard to say which way you're going from left to right, whether you're going -6 because you're going down, or maybe you think of this point as the starting point, you're going up. So it doesn't matter. One way or the other, it's either +6 or -6. But it doesn't matter whether it's +6 or -6, because how much do I move from left to right from this dot to this drop, or this point to this point? And the answer is none. And have we had this conversation yet? Why can't we divide by 0? Why is it perfectly acceptable to go 0 divided by 6 is 0, but when I try going 6 divided by 0, I get what we call mathematically undefined? Why can't we divide by 0? Well, this is a little off topic, so you don't have to bother writing it down. But think about what divide means. What does it mean when I ask you what 6 divided by 2 is? Well, dividing is actually repeatedly subtracting. So this asks you the question, how many 2's can you take away from 6 before you run out of stuff? So if you have 6 things, 1, 2, 3, 4, 5, 6. Okay, I'll take away 2. That's one group. I'll take away 2. That's another group. I'll take away another 2. The answer is 3. I can take away 3 groups of 2 from 6 until I run out of things to count. Right? That's what division is. It's repeated subtraction. I can take 3 2's away from 6. So now, if that makes sense to you, notice that this question does have an answer. How many 2's can I take away from 0? None. I don't have anything to take away. But notice this question doesn't have an answer. How many 0's can I take away from 2 before I run out of stuff? Well, I'll never run out of stuff. And because that whole I could never run out of stuff, I could keep taking away 0's forever, you get the odd person, maybe you've even had somebody try to convince you that, oh, the answer to this is infinity. Actually, no, it isn't. Right? Because even if I did take 0 away from 2 infinite times, I don't run out of 2. I still have 2. This does not have an answer. There is no mathematical way for me to explain to you how many 0's I could take away from 2 before I ran out of things. So I have no choice but to say that this isn't mathematically defined. It's undefined. Another good way to explain this is that you can, of course, reverse this statement and say that, well, 6 divided by 2 is 3 because 2 times 3 is 6. 0 divided by 2 is 0 because 0 times 2 is 0. There's no answer that can go here because there's absolutely nothing you could multiply 0 by to get to 2. Once again, people who want to call this an infinity answer, does infinity times 0 make 2? If I had infinite zeros, would I count that up and say that I have 2? Nope. There is no answer to this. So, if it's never really been explained to you why you can't divide by 0, that's kind of the crux of the argument. We can't count and divide by 0 using the same number system. So, the slope of a vertical line can't be calculated. It is undefined. All right, now I'm going to go backwards on mine. Yours is underneath. Back to example 1. Right, that is your example 1, right? Yeah. Okay. So determine the slope of this line segment. So first of all, I would like to maybe show you what symbols I use. I use m, little m for slope. And if I'm going to go from a point to a point, if they give me names on the points, in this case the name E and the name F, sometimes I like to actually put m with a little subscript EF, which is, again, kind of the English on that is the slope of line segment E to F. Technically, EF is not a line, it's a line segment. Line implies that it goes forever. That thing clearly begins at E and ends at F. All right, first of all, do you expect this slope to be positive or negative? Look back at the rule. It's going up when I go left to right, so it's positive. And keep in mind, it's rise over run. So how much does it rise to get from E to F? Well, it goes, that'd be -5, so it goes up 5 to get to 0, then 4 more to get to the 4. So this is a rise of 9. And how much run does it have? Well, it starts here and it moves over that way. So horizontally to move from E to F, it's a move of 1, 2, 3, 4, 5, 6. Have I counted that right? 1, 2, 3, 4, 5, 6. Yeah, okay, 9 over 6. And if I left my answer like that, I'd lose half a mark. What do I notice about 9 over 6? I can simplify that fraction. So I would simplify it to 3/2. I don't really want a decimal. We don't usually express slopes in decimals unless we're doing some sort of word problem where perhaps the slope represents velocity of a line. Some of you have seen that in your science classes. And yeah, you'd probably want your velocity to have a decimal on it. But for the most part, we'd rather leave it in a simplified fraction form. All right, let's calculate the slope from G to H. This time, to get from G to H, I have to go down 3 units. So my rise is a negative number. I have to go down 3. And then I have a run of 1, 2, 3, 4, 5, 6, 7, 8, 9. Once again, I get a fraction I can simplify to -1/3. All right, let's see if we can do what we just did backwards. If we can find the slope given a line, what if I tell you what slope I want and I ask you to make me a line? Now, it doesn't really matter where you start. Start anywhere. Tell you what, since the bottom is a 9, the run is a 9, I'll start over here at -9. So starting at -9, let's rise 4 and run 9. So if I rise up 1, 2, 3, 4, and I run over 1, 2, 3, 4, 5, 6, 7, 8, 9, there we go. Try to connect that with a straight line. That slope has that line segment has a slope of 4 over 9. Now it doesn't matter where I started. In fact, here, let's do it again. Let's start at the point -5, -5, right there. Rise 4 and run 9. 2, 3, 4, 5, 6, 7, 8, 9. What do I notice about my 2 line segments? They're parallel, right? They would actually never cross even if they can continue forever. All right, now let's do one with a negative in it. So I already have kind of a picture in my head. This line segment's going to go down as I go left to right. But look what they do with the negative. They stick the negative kind of in the middle of the fraction. Again, this is a bit of an aside. This is, again, something you should have talked about early in grade 9. Those three numbers are all the same number, right? If I have a fraction, it doesn't matter if I put the negative on the top or on the bottom or kind of right in front of the whole thing. Think of fractions like they're divides. Negative 1 divided by 2 is 0.5 with a negative on it. 1 divided by negative 2 is negative 0.5. And 1 divided by 2 is 0.5, but if I want the negative of that, they're all the same value. So it doesn't really matter which way I do rise and run here. I can say that I have a rise of negative 8 and a run of 3. Okay, let's pick a spot to start. Let's start over here. Well, if I have to go up 8, I better make sure I start somewhere down here. So let's start at negative 6, 1. There's a good spot to start. We'll start at negative 6, 1. So I'm going to rise negative 8. So that means I'm going down 1, 2, 3, 4, 5, 6, 7, 8. And then I run over 1, 2, 3. So there's my, I'll try to draw a straight line here. Pretend that's just, oh wait, we're just making lines. Oh, I can put arrows on it. It doesn't matter if it's a line or a line segment. Either way, it has a slope of negative 8/3. All right, now let's try it the other way. What if we decided that negative belongs to the bottom number, and it has a rise of 8 and a run of negative 3? All right, let's start here. Let's start over at 8, 0. So we're going to rise 8, which means we go up to 8. And then over, I guess I didn't really want to dot there. Why did I do that? Sorry. And then we go over, so that's a rise of 8, and then a run of negative 3. Which way's negative back and forth? To the left. 1, 2, 3. And there we go. Notice, once again, I have a line that is parallel looking. Oops. Oh, hang on. I'm moving my page. I didn't mean to do that. Oh, that's terrible. Let me try that again. That one's better. Make a bigger dot when you miss the dot you're aiming for. Those two lines, again, should be parallel because they have the same rise over run. And what's cool about rise over run is I actually don't even really need to see a picture to do it. We can determine the slope of a line given 2 points just in coordinate form. If we are told the coordinates of 2 points, I can call the first point x coordinate 1 and y coordinate 1. I can call the second point x coordinate 2 and y coordinate 2. And then my slope formula, and we kind of saw this a little when we were reviewing grade 9 stuff, is this formula right here. y2 minus y1 over x2 minus x1. This is what we tend to consider the slope formula. And example 3 is nice enough to actually give us a picture, but we actually don't really need it if we just know the coordinates of the point. So I'll read a couple here. This one's 0, 6. And let's do one up here. What is this one? This one is 5, 6, 7, 8, 8, 6. All right, let's find the slope. So I'm going to call this x1 and y1. And I'm going to call this one x2 and y2. So let's use my fancy new formula. My formula is slope is y2 minus y1 over x2 minus x1. So plug in those coordinates. 6 minus 6. Oh, hang on a sec. I just misread this point. This one should be negative 6. That's better. Hang on. Let me fix that. 0, negative 6. That's better. Okay. So 6 minus negative 6. You can write it like that if you want. 6 minus negative 6. And then once again, I lost the negative. Hold on. There, that's better. Over 8 minus 0. That's going to give me a slope of 12 over 8. which I can simplify. They both have a 4 in them, to 3/2. What's cool about this is it shouldn't have mattered which points I picked. Let me pick a couple of different ones. In fact, how about I pick two that are closer together? Got a different color? I'll do these ones in blue. Let's say I pick this point. This looks like it is 6, 1, 2, 3. And this guy here is 2, -1, -3. And this will be my x1, y1, and this will be my x2, y2 this time. So let's use the same formula. y2 minus y1 over x2 minus x1. Only let's use the other 2 points. So now my y2 is 3. My y1 is -3, so minus -3. And x2 is 6. And x1 is 2. Looks like I'm getting a different number until you look at it more closely. What can you do with 6 over 4? You can divide top and bottom by 2. And you get the same thing. The slope between any 2 points on a line is constant. Feel free to pick other ones if you want. You could go 6 minus -3, which is 9, 8 minus 2, 9 over 4, 3/2. It really wouldn't matter where you picked. All right, that's the basic gist of how the slope formula works. Let's do one where we don't even get a picture. Determine the slope of the line that passes through points E and F. So the slope from any 2 points is, let's write the formula down again, y2 minus y1 over x2 minus x1. And we would like the slope specifically from E to F. So that's going to be, so I'm going to call this x1 and y1. I'm going to call this one x2 and y2. So that's going to be 6 minus -3 all over 8 minus 4, which is 9/4. Now, did it matter which one I called x1 and which one I called x2? The answer is no. I tend to read from left to right, as I think most of us do, so I tend to pick the first point as the one I'll call 1 and 2. But I didn't have to. Let me use a different color. What if I'd have called this one x1 and y1, and I'd have called this one x2 and y2? So then I would have been finding the slope from F to E. So then I would have had -3 minus 6 over 4 minus 8. And please notice I get -9 divided by -4. And what happens when you take a negative divided by a negative? Yeah, they just cancel each other and you get a positive anyway. It wouldn't matter. This formula is kind of forgiving that way. It doesn't really matter what order you do it in. The only way you could goof this up, other than making an integer mistake, is if you call one of the coordinates. If I call this coordinate x1, I can't call its partner y2. Right? If I had mixed up, if I said 3 minus 6, but then I said 8 minus 4, whoops, I wouldn't have a negative down here to cancel the negative on top. And you know, there's kind of a nice way to kind of correct when you see mistakes like that if you're looking at a picture. If I had sketched where these 2 points are on a grid, I would have clearly seen that, oh yeah, this is going to be a positive slope. It moves up as I go to the right. All right, your turn to try the formula. Determine the slope of the line that passes through A and B. And I don't care which one you call the first point or the second point. I don't care if you find slope AB or slope BA, they should be the same thing. But I'll give you a sec to try it yourself. See if you can get the formula to work for you. And yes, I want the final answer as a fraction unless it turns out to be a whole integer. Give it a try. Okay, let me see if I can catch up to you. I would go 4 minus 6 over 3 minus 1 and get negative 2 over 2. And I don't want to leave the answer like that, so I will leave the answer as negative 1. Slopes can be integers. If you left your answer as negative 1 over 1, that's fine, but please notice that divide by 1 doesn't really mean anything, so I think we'd prefer the integer. All right, and then the C part of the question is, can you sketch both of the lines? So E to F and A to B. So let's sketch those lines. So the first one is 4, negative 3, and 8, 6. So 4, negative 3, and 8, 1, 2, 3, 4, 5, 6. So which one was which again? E, then F from left to right. So this one was E, and this one was F. And again, try to make a nice straight line. Oh, that one's good. I like that one. And then the other line went from 1, 6 to 3, 4. So 1, comma 6 to 3, comma 4. Okay, now it does say that they're lines, so I should probably put arrows on them. It doesn't say that they're line segments. And again, make a line. Just out of curiosity, where do you think those lines would have intersected each other? It looks to me like it would have been like 6, 2 maybe, somewhere around there. Later on this unit, we'll learn mathematical ways that we can find where those intersection points are without even actually having to graph. But that's coming up. That's it for today's lesson. I told you it was kind of quick. So let's give you some time to do some work, and then you won't have any homework. Hang on a sec. I can stop the lesson here. Okay, you guys can go to the blog in a minute here. Thanks for watching.